Hello, welcome to day 24 of NTI for Algebra 1. This is the worksheet that you will be getting today. Only by the time you guys see it, number 1, number 4, and number 7 will be worked out as examples for you. So before I show you how to work out number 1, I'm going to show you how number 1 relates to what we've been doing. Over here you see question number 1 from day 16, and it's all the way worked out. The directions on day 16 were to factor the trinomial. What if I changed one thing? What if I changed the directions to say solve, which is what your directions are today? And if I changed one more thing in this question, and I made it into an equation where it said equals 0. Once it's an equation, I can solve it. So this number 1 from day 16, the answer to it, we're going to just finish working out the problem today, is going to be your number 1 on today's worksheet that you're going to get to see. So on number 1, you can see I have 3 parts. The number 3, then x plus 3 in parentheses, x plus 4 in parentheses, equals 0. The 3 parts that I'm multiplying together to equal 0, that's the side where I need to do some solving. You should remember that for anything to equal 0, one of the things you're multiplying has to be 0. Well, 3 can't be 0. But if x plus 3 was replaced with 0, 3 times 0 times x plus 4, anything times 0 would be 0. Or if x plus 4 got replaced with 0, 3 times x plus 3 times 0 would be 0. Which means in order to get this answer of 0 to solve this problem, one of these things in the parentheses has to be 0. So I'm going to make 2 smaller problems. X plus 3 might be 0, or x plus 4 might be 0. If either one of those things is 0, then I can get 0 for the answer. Now, this ties into what you did yesterday where you solved some 1 and 2 step equations. To solve this problem, what I would do is divide down the equal sign and do the inverse operation right here to get rid of this plus 3. That inverse operation is minus 3. You have to do it on both sides. On this side, 3 minus 3 is 0. So x plus 0 is x. And on the other side of the equal sign, 0 minus 3 is negative 3. So negative 3 is one of my things that I could put in the place of x right here, and that would make this part 0. Let's talk about the other parentheses. X plus 4 equals 0. Same thing, it's a one-step problem. I need to use the inverse operation of plus 4, which would be to subtract 4 on both sides. When I do that, 4 minus 4 is 0, and x plus 0 is x. 0 minus 4 is negative 4. What we really did, and you can't see it in solving this equation, is we have found the 2 x-intercepts of a parabola. So in this case, if I had just a quick sketch, a parabola, it would be over here, and the 2 places that it crosses the x-axis would be negative 3 and negative 4. So we can write this answer as showing the x-intercepts. My first answer would be negative 3, 0, and my second answer would be negative 4, 0. The 2 options for x are negative 3 and negative 4. All right, let's look at number 4. On number 4, you can see 2x plus 3 times 3x minus 4 equals 0. I'm multiplying 2 things. One of those 2 things has to be 0 for my final answer to be 0. So we're going to do like we did on number 1. We're going to make 2 separate problems. The first one, 2x plus 3 might be 0. Or the second one, 3x minus 4 might be 0. And then we're going to solve those problems. Those problems are like some of the ones you did yesterday, 2 steps. So we're going to use inverse operations, but these are going to take 2 steps to solve. The first step to solve number 4 is to subtract 3 on both sides of the equal sign. When I do that, I'm going to bring down 2x equals negative 3. I still have to divide by 2 for inverse operations, so I'm going to divide by 2 on both sides. And I get x equals negative 3 over 2. That is a simplified fraction, so that is an acceptable answer for x. I don't really want you to plug that in your calculator and get a decimal of negative 1.5. If you do that, just to check if it is a simplified fraction, don't forget that you can use math enter to come back to your simplified fraction. Now let's go to the second problem. The second problem, 3x minus 4, my first inverse operation is to add 4 on both sides. When I do that, I'm going to bring down a 3x equals positive 4. The second inverse operation is to divide by 3, and I get x equals 4/3. X equals 4/3. 4/3 is a simplified fraction. I'm going to show you over here on the calculator just in case. So just in case you need the calculator, you can see I pulled up the TI-84. I will put a link to this if you haven't already added it to your Chromebook so that you can use this. So I'm going to take this 4 over 3 as an example. Maybe I'm not really secure in fractions. Maybe I think they're hard, or I never know if they're simplified enough. So I'm going to come over here and I'm going to use this calculator and just type in 4 divided by 3. And it gives me this long repeating decimal, which teachers don't usually like you to try to give as an answer. So don't forget, you can, on the calculator, you can click math, enter, and it takes it back to the fraction 4 over 3, which lets you know 4 over 3 is the most simplified fraction. That's why I left 4 over 3 and circled it. If I write my answers as ordered pairs, my 2 ordered pairs would be negative 3 over 2, 0. That's one of the x-intercepts. And 4 over 3, comma, 0. That's my other x-intercept. And here's the last example. On the last example, we have 3x minus 2 to the second power, or squared, equals 0. Remember that 2 to the second power means 3x minus 2 has been used twice. I'm only going to solve one of these because I do already know that if I solve both of these, they're going to be the same answer since they're the same question. So I'm just going to solve 3x minus 2 equals 0. To do that, I'm going to use my inverse operations to do a 2-step problem. The first operation is to add 2 on both sides, and I get 3x equals 2. That should be a 2. And then the second operation is to divide by 3. So dividing by 3, I'm going to get x equals 2/3. If I write that as an ordered pair, I'm going to have an ordered pair 2/3, comma, 0. So this may be the first time that we've had only one x-intercept. So I want to show you what that actually looks like when you're on a graph. This red one is question number 1, where we got 2 x-intercepts. We got -3 and -4 for our x-intercepts. This green one over here is the question we just did, where it only touches the x-axis once. So that's why we only got one ordered pair for our answer. Sometimes that happens. Don't forget to show all of your work for the remaining problems, and number 9 is optional.